What's up, everyone? Dave the Data Dude. Today we are going to be talking about the introduction to pivot. We're going to be talking about how you can take your vertical data and pivot it on certain columns and create a new data frame of more horizontal or vertical data for end users to have an easier time of looking at data for business decisions, for inventory, for a whole host of other reasons. But let's go ahead and jump into it, take a look at what we're going to be doing with our pivot. First, we're going to start with importing Pandas as PD. We're going to import our Pokemon CSV and read the first 5 rows to make sure everything looks correct. And it does. So we're going to go ahead and jump into the pivot by calling the PD, because it's a Pandas function, pivot table. And in the pivot table, you have a lot of options. We're going to talk about most of these options. And we're going to talk about what you can do with them and some examples of how they might be useful in your business. So the first thing we need to do is tell it what is the data we're looking at. We're looking at our Pokemon data, which is assigned the DF variable. From there, we're going to set the index. The index is going to equal legendary, right? Because that's going to be our legendary column, right? So all of the values in our legendary column are going to be aggregated and indexed. From there, we're going to tell it what columns do we want to have. So columns equals type 1. So what this is essentially going to do is on our legendary index, we're going to assign all of the values of type 1, all the distinct values of type 1, a column. So grass will be a column, fire will be a column, rock, poison, all of those will have their own column because they're a distinct value of the type 1 column. Okay? So then we're going to set the values equal to total, which is just the summation of all of these columns put together. So 318 is just the summation of all these put together. And what that's going to do is it's going to take our index, which is our legendary column, and in the columns of the values of type 1, it is going to give us the values of total. And we're going to say aggregate func for aggregate function equals mean. That is the default. If you look in here at the shift tab, you'll see that the mean is the default. But we're going to go ahead and reference it just because we're going to change it in here in a second. So let's see what this looks like. So we see that legendary false type 1 of bug has a mean value of 378. This one is null because there are no legendary bugs, right? So here we see dark, false. The mean value of dark, non-legendary Pokemon is 432. Now, an easier way to look at that, because those are kind of obscure numbers, they don't really mean anything to us as, just looking at them. So we're going to do count. And we're going to look and see that there are 2 legendary dark Pokemon. And that's easy to check. We can do df.lock. We're going to do a multiple arguments because it's going to be legendary and dark. So we're going to start with a parentheses, df type 1 equals dark. And another argument, df legendary. And this is a Boolean, so we just say true. And we see that we have 2 dark Pokemon. Two dark Pokemon that are legendary. And we see that represented here. And we could check all of these if we wanted to and take a look at them and see that that is the way that it aggregates this data, because we told it to just give us the count. Same way we could say sum, right? And we could easily see that, okay, so it's 1280. We would just say 200 or 600, 680 comes out to 1280, and it does. Okay, but let's keep it at count just because it's easier to kind of visually see just when we're working through it. So another option you have within the Pandas pivot table is you have the fill value. So this is going to say, what do you do if it is null? Well, we're just going to set it to 0, right? Because we don't want it to do anything really with it. Makes our data look a little cleaner. It removes the decimals because it's not being converted to a float because of NaN, not a number, because that NaN is considered a float. So now it's a whole integer, and we don't have any floats. So we have 29 dark, 2 dark, no legendary bugs, no legendary poisons. Okay? So let's now take a look at what we would do if we wanted to have a multi-index, right? So we know that making multi-index, you just, if you have multiple arguments, you make it a list, and we're going to now make it generation, right? So here, now we see that under false, we have 6 generations. Under true, we have 6 generations. It did that for us automatically because there's 6 generations in this data set. We have 14 bugs. We have 14 bugs in the first generation, 12 bugs in the second generation, so forth and so on. Looking at our example down here, we have a 4th and a 6th generation. So we see true for our legendary, right, because we indexed on that. Then generation, we see that it's 4. So we come here, go to dark, and we see 1. And that matches. 6, and that matches. Okay, so you're kind of starting to see how you can use your pandas to take your data and make a pivot table. We're not here to talk about necessarily all that a pivot table is, but you can see how you can use this for end users to make reports, make business decisions. If this was like a state and this was a city, they could easily see in New York, you know, whatever, Albany, there are 10 bugs. There are 2 darks. There are 4 dragon, right? So forth and so on. If these were, you know, inventory items like, you know, 18, I don't know, whatever, keyboards, 13 employees, 4, you know, offices. You see how you can make these reports that end users can just look at this data and easily, simply see what this data is. So we'll take it another step and we'll look at, we will look at the margins. So what margins is going to do is take the sum, I guess, of all of this data and put it here as an all column. So let's take a look at what that looks like. Margins equals true, right? It's defaulted to false, so we're just going to set it to true. So 160. Let's do an easier one. So 5. So we got 1, 2, 3, 4, 5. We've got 5 legendary generation 2 Pokemon. So it takes it and makes this data and just sums it, or gives you the total, right? So you can see that is your margin. Now you can go even farther with that margin. You can just give it a name. So we'll just say margin name, margin's name equals, and we'll call it total Pokemon gen. So now we can see total Pokemon gen, 160 type 1 or generation 1 non-legendary Pokemon, right? And that's how you can make a report that end users could take. They could use it, they could then name it, and they can easily see a list of reports for all of these different types of categories, and you can do whatever you want with it. If you wanted to say sum because all of these things might have been sales profits, you can say that too, and you'll come over here and it gives you the sum of all of these put together per index. Okay? All right, so that's all we're going to talk about today with our pivot. We talked about how we can make a pivot, some of the things that we can do with a pivot, removing the nulls from the pivot by just setting them to 0 in our example, how you can aggregate those data, how you can aggregate that data on different options like sum and mean and count, and how you can even take the horizontal summation of those data, of those rows, and make it something that end users can see a real quick snapshot of all of your data. So like and subscribe. Let us know if you have any questions or if there's anything that you'd like to see so that we can keep bringing you further content that you enjoy. Thank you very much.